Good evening. My name is Michael Londesborough, and it's a big pleasure and a delight for me to welcome you on behalf of Czech Centres London to the latest AI, that's Artificial Intelligence, Science Café. So the AI Science Café is a series of Science Café which have been set up by the Czech Centres in London in cooperation with the Royal Institution. And so far it's covered a series of AI topics, including personal and cybersecurity, autonomous mobility, robotics, and wildlife preservation. But today's presentation will be on conversational AI. So this is particularly interesting to me as I'm beginning to use this particular technology myself with my mobile telephone. So when I need to know where is the nearest Italian restaurant, or when does the next train to Prague leave, or what is the score in the game, I ask my phone often, and it gives an answer which is rather impressive. So all these are questions we're increasingly using our devices, our robots, mobiles, and others, and not only for factual questions, but even for opinions, or I can even ask it for a joke. Could you tell me a joke, please?
What do you call a can opener that doesn't work? A can't opener.
Very funny. So, leading the development of this technology is a man that I have with me today, Mr. Dr. Jan Šedivý, who's going to be telling us more about conversational AI. Jan has led many worldwide research and development projects. He was a principal designer at IBM. He holds 19 US patents. His areas in the field are numerous, and he's currently a faculty supervisor of Alquist AI here in Prague. So Jan, welcome.
Good evening.
Good evening. So I'm very much looking forward to learning more about how this technology works and what are the implications of this gaining momentum that you're developing in this technology. And maybe we'll have time as well to discuss what the future might hold for our conversations that we do have with our mobile telephones, our cars, our robots. Something about the structure of this evening. Later on, Jan and I will be talking about these very questions and matters. And then also you'll have an opportunity to write in with your own questions, which Jan has agreed very kindly to answer. But before we begin that part of the discussion, we will start with a presentation from Jan, about 20 minutes long, where you can introduce the subject yourself and your current progress. So Jan, I'm going to hand over to you, and the floor is yours for 20 minutes.
Very good. So I will start with the presentation, which will give you the basic idea about the technology, and then I will talk a little bit about our project, which is called Alquist. Actually, the name Alquist is the name of a character from the Karel Čapek's play RUR, Rozum si Universal Robots. So the title of the presentation is Alquist, the social bot. And first of all, let me tell you something about the advances or the recent advances in AI, specifically about speech recognition and text-to-speech, because conversational AI is about the most natural way of interacting or communicating, which is obviously language. When we talk, we are learning the most, or the talk is giving us many more aspects of human beings, how the people behave, about their emotions and so on. But unfortunately, we don't have this information in our bots. We are limited to ASR and speech. Since I was part of the whole development of speech recognition from the very early beginnings, I was around when we put on the market the first dictation system, and then I was the key developer or the key designer of one of the first car assistants, which was even in the early 90s already capable of recognizing some very simple commands or some very simple questions, which was all the speech recognition that time was in its infancy, and speech recognition error rates were very high. For example, for the dictation, which emerged like 95, we had to use isolated words, so we had to make spaces between words so as the system understands. I would say that one of the newest approaches or one of the newest applications was Google search, or voice search, which surprisingly enough was first launched on iPhones because it was launched before Android was actually put on the market. And then after Android emerged, then there were other systems like Google Now. And in 2016-14, the first versions of Alexa and then later on Google Home intelligent speakers were put on the market. And these intelligent speakers, this is already the latest technology, which is based on the very recent improvements in speech recognition. Around 2013-14, we discovered new ways how to use neural networks, and the huge amount of computational power as well as huge amounts of data we collected on the internet from the users. This was the enabler to create better speech recognition. Google, for example, these days claims that they have the accuracy like 94% on many different devices. And this is according to what Google says, and this is probably in double quotes, or we have always questioned it, but it's 1% better than average person. So the speech recognition made tremendous progress, but as you would expect or as you would guess, obviously the system are still making problems or making errors. And the last two lines on this slide are showing the very latest advances in speech recognition, which we address as conversational AI. And last line talks about our contribution, and this is the system or the social bot called Alquist, and I will be talking about it soon. On this picture, there are the two major devices. Actually, both of them are less than 1 month old. On the left-hand side, we can see the Amazon Echo, and Amazon was pioneer in these intelligent speakers. And on the right-hand side, we have Nest Audio, which is a successor of Google Home. They actually renamed the whole brand, and it's now closer to the very successful Nest thermostat. And on the next picture, I have something which is showing the popularity or the size of customers who use these devices. As we can see, Alexa was very strong in the early beginnings, and as soon as Google joined, it started to grab a little bit larger and larger piece of the pie, and these days they are a real competitor to Alexa, even though I would say that Amazon as well as Alexa are approaching the field slightly differently or are going in a slightly different direction. So we'll see how the things will evolve. Certainly all us working in conversational AI, especially in academia, we would be happy if we had one standard and not too many standards, because having one standard, many people can contribute and reuse the standard in a form of API, for example, for third parties devices or built on top of single infrastructure. Such standard is, for example, GSM. Worldwide, you have GSM phones and you can use it everywhere. So the next slides are showing us what are the applications or what is most frequently or for what are most frequently these intelligent speakers used by our customers. So one of the very important, or one of the starting idea was answering factoid questions. And as you would see, or as you would guess, this is a thing which we thought will be very frequent one, but the latest studies or the market says that it's probably the third place, because the most frequently used application is to play music like Spotify or Amazon Music, etc. The second one seems to be these days using these voice intelligent speakers for controlling home devices, which is usually advertised under the IoT, Internet of Things acronym. And obviously, you can imagine that in some cases it might be good help if you go to your garage and you can say, open the door, because before it rolls up, it takes some time, so you can shorten the time. Or if you go to cellar, which is dark, so you may say in advance, say something like turn on the lights in the cellar. But in the everyday life, like getting to the kitchen or to your living room and saying turn on the lights, or preceded by Alexa or Google Home, doesn't seem to be handy. So I am sure that there will be still strong development in this direction, and we would be able to use very short commands to turn on the lights or adjust the temperature in the room, etc. So this is definitely one of the areas where we will see big progress. The last line shows that these days we have also a lot of applications which are sort of conversational one, and you can install them, and then you can talk to Alexa or Google about basketball or about I don't know, psychological therapy, etc. There are like 100,000 of them, so the discoverability is a big problem. To find what you really want or what you really enjoy is not simple. And now I will start to talk about our social bot Alquist. Actually, in the background, you can see our National Technical Library, which is a great building. Therefore, I use it as a background. And we will start with description of what it is really, a social bot. And this definition comes from Amazon. Amazon, and I will talk about it a little bit later, organized a competition for academic teams, and part of the competition was a definition of what the teams are supposed to build. And they used the name social bot. So as the name suggests, the bot should be very social and should talk about the very frequent or popular topics such as sports, movies, TV shows, probably politics, celebrities, etc., etc. And there was the main task behind this competition was to challenge the teams to be capable to carry an interesting talk for 20 minutes. The team who would be the first tested on several customers, and the customers would keep conversing for longer than 20 minutes, will get the grand prize, which is $1 million of US dollars. These days, we are approaching several minutes. Sometimes we get over 10 minutes, so we are still far away, but it's not a simple task, because the bots, as they are tested in this competition, don't have memory. So they don't know about the speaker anything. They don't do profiling, or we cannot do profiling, like, remember, this guy has a sister and this guy likes cricket or any other game. So therefore, the talk is not very social, because you can imagine if you get in a bar and there are like 10 guys hanging around having already a lot of alcohol, how would you address them? And that's a very different task than if you go, for example, to a playground and there are moms sitting with their kids. So the conversation will evolve completely differently. And in both cases, you don't have any background except of seeing a bunch of guys being drunk and then a group of girls talking about their kids. So this is the difficulty. We don't know whom we are to talk to. So this is the team. The team these days is larger. This is like 1.5-year-old picture. And here is the challenge. It was actually funded with $2.5 million US dollars. And the next slide, which will follow, will show you some very pre-recorded simple conversation. We have the Alexa with the conversational system here too, so we may try to later on give you some real-time demo, but let me start the YouTube video.
Alexa, open Alquist.
Hi, this is an Alexa Prize social bot. Is it you again, Andrew?
Yeah, it's me.
What a faithful chatmate you are. How are you today?
I'm pretty good, thank you.
Hip hip hooray! I'm happy for you, Andrew.
Let's chat about movies.
I was wondering, who is your most favorite actor?
I like John Travolta.
John Travolta, really? What an interesting choice. Can you tell me, why do you like this actor that much?
I like the movies that he's in.
Oh, so that's why John Travolta is your favorite. I had never thought of John Travolta when I asked you. Now that I think about that, I think I like this actor too. However, my favorite one is Harrison Ford, because I love Star Wars. Well, I guess you are a good cook, right?
No, I'm not.
And is this something you think about yourself, or is it scientifically proven?
Well, I think it could be proven scientifically very easily. I'm not a good cook.
If it's science, I can't dispute it.
Okay, this was the video, and now let me very quickly tell you what's behind the conversational AI, or what's behind Alquist. So on this picture or on this graph, there is schematically shown what are the major parts. On the left-hand side, we have the latest Alexa. And the Alexa is actually connected to the internet. So what is in this large gray frame, this is everything somewhere in the cloud. Typically, when we use Alexa, it is located in data centers in North Carolina. And from the Alexa, the sound goes to the upper left corner piece or node, and this reflects or shows the automatic speech recognition, which is a system converting the sound to text. And then the text goes further on to the system, and the main part is NLU, which is Natural Language Understanding or Natural Language Processing Unit, which is extracting the major characteristic of the sentence the user said. And then we continue with a dialogue manager. The dialogue manager may get help from databases or may get help from a question answering system. And then we go to something which is called NLG, which is natural language generation. And this part of the whole system generates a text which is a reply to what the user asked or to what was the user message. And then the text-to-speech piece is actually converting this text to sound, which is then played back through the speaker inside the Alexa. So the ASR as well as TTS, text-to-speech, which are in the smaller grayish rectangle, these are the two pieces which we use from the Alexa. The other nodes or the other rectangles on the picture, this is our technology, and our technology are so as to materialize it, programs, and these programs are located on Amazon Web Services servers, it means in the cloud. So as to be able to really carry an interesting discussion or conversation, we have to have some knowledge. So the system needs to know what is cricket or what is Autobahn or what is Prague Castle, etc. And we have to get the knowledge from somewhere. So one of the major source of the factoid answers to factoid questions is Wikidata. Wikidata is a database which was derived from Wikipedia, and if you go to Wikipedia and you type, for example, Václav Havel, you can see a box which is called info box on the upper right side, and the data which is in this box, this is all included in Wikidata, and we have access to it. We don't use just the Wikidata, we use Twitter, we use also the data from Washington Post. For movies, we use IMDb. For songs, we use Last.fm, and certainly a very great source of information, and especially a great source of interesting facts or jokes or etc. is Reddit. So these are the major things which we include to our conversation to make it interesting or to make it funny. Here is a simple dialogue, and the dialogue is here in a form of a graph. So the graph is actually showing in these in these green rectangles what the system may say, and the blue rectangles are the expected phrases from the user. So the whole conversation runs in what we, sorry for saying scientifically, but what we professionally call turns, where the turn is always something what the system utters, and then the reply, it is what the user utters, and this is called turn. So each turn is processed with some kind of a dialogue which is shown here. This is actually showing 1.5 of a turn, and in between there is some business logic. In between are the accesses to databases, and lots of other things may take place before we can actually answer. And as you can see, in this example, we are expecting 3 different classes of answers to actually be able to recognize what the user answered or what the user asked for, depending on the type of a turn. Then we use the NLP algorithms, which are helping us to distinguish that. Here are some of the basics and some of the terms we use colloquially for actually trying to extract the information, trying to extract semantics. And the 2 major ones are intent, and the other one are entities or keywords. Entities are reserved for material stuff, and keywords for something immaterial like songs, etc. And the NLP algorithms are allowing us to classify what is the intent. So we may have 2 sentences which differ or which are showing the difference. When I say, for example, what is the weather? It is clearly I want to know the weather forecast, or I may say what's the traffic situation, which is obviously something different than weather. So intent 1, intent 2. And if I say what's the weather in London, then London is material, this is an entity. And if I say what's the weather in London tomorrow, I am adding another entity which is time, and in this case it is tomorrow. Having this information or or being able to extract this information from a question, we can call a service like weather.org on the internet and request what is the weather tomorrow in London, and we get back some data, and from this data we create, using the NLG, as I have already mentioned, a sentence which is then sent to TTS and the user gets the answer. So it looks simple, but believe me, it's not that simple. So here are some other technologies which are taking part in the process of conversing. This is just for your information. I wouldn't go now deeper into each of them so as to stay within the limit. This is maybe something what is very important, because all these companies are very sensitive to be politically correct. So it's impossible to use any profanities or anything which is bad, and this is really very difficult task, and we cannot do it. We have one funny story. It happened before Christmas when the employees of Amazon were asked to get their kids to the office, and then they started to use Alexa, and the kids were talking about Christmas, and suddenly there was an answer that Santa is dead, which is obviously very difficult to recognize as an insensitive or politically incorrect answer, because Santa as well as dead are reasonable or no problem statements or no problem words, but certainly in this context it's something which is not nice. And this is probably the last slide of the presentation, and this is showing one of the referees, because the competition, the Alquist competition, always we were asked to do for a period of 3/4 of a year or almost a year the social bot, and then at the end all the bots which made it to the final were used by customers, and to make the final decision Amazon selected 3 judges and 3 interactors. Interactors were people who were talking to the Alexa, and judges were listening to. And at a point where the conversation started to be boring, each of the judges was asked to push a button. As soon as all 3 pushed the button, the interaction was stopped, and based on this data, they evaluated the teams. Our team, Alexa team from the Czech Technical University from Prague, we were very lucky because we made it 3 times in a row to the final. So we were 3 times in a row between the top 3 teams, twice second, once third. And this year we are slowly but surely preparing for the next round, and we'll see if we make it between top 3 again. So that's probably the whole story.
Well, that's a nice place, I think, to finish. And I'd like to immediately add on to that a big congratulations for your success from Czech Technical University here in Prague at these Alexa prizes. So I want to sort of dive into certain aspects of the technology, and then move on to discuss what the implications of the technology are and will be in the future. So one thing that came out of your fascinating presentation was that you mentioned that there's a 94% accuracy of speech recognition in some of your systems, which is better than most humans.
Well, actually, I have to say that the ASR we use is either we don't do our own ASR.
Right, the ASR, which is the automatic speech recognition, is in South Carolina somewhere.
Yes, exactly. So it's either Amazon or Google.
Okay, but let's go into that for a moment, because every language has various nuanced expressions, sarcasm, many different accents, slang, profanities, which maybe they can't repeat, but they have to understand, I presume. So there's all these contextual aspects of language. How does your system cope with these?
Well, the ASR, that's only the first part, and the role of ASR is to convert what we said and what was picked up by a microphone and then over the internet fed to the center. And the ASR is converting what is coming into a text.
Okay, so that input file, because when I'm speaking to you now, I've got vibrations of my vocal cords. That energy is producing a pressure wave, which is propagated along the molecules of air that go to your ear, where it's amplified and converted into a message that your brain can conceive of. So it's not too different with your devices, but the pressure waves are entering the system here. That's being converted into a digital signal. That signal is going to Southern Carolina, where presumably that sort of fingerprint, that signal is being compared on a database with...
Well, it's not these days. Most of these ASRs are using the neural networks, and it's not exactly comparison. It's more classification, and speech is composed from phones, but the phones have co-articulation, so we use typically triphones or maybe even more than triphones, and based off recognizing this very small pieces of what is coming to the system from the acoustic pressure, we actually are able to recognize words. And it's quite complicated because if you consider, for example, a phone dictionary, then you have, like in the UK, a lot of other people who have strange or non-English names, like, I don't know, Rajesh and Gopal Krishna, etc., Nahamu, and you name it. So there are many different. So we have to do the best systems today do the phonetic recognition, and they understand even these words which are not usual in particular language.
And of course, languages are always evolving, and new words come in, new ways of saying words develop. So I presume that the people looking after the automatic speech recognition have to be continually updating their system.
Yes, the systems, the speech recognition systems are repeatedly trained, and they are trained on a language which is being recorded when people talk to phones or at different occasions or coming from different systems. And the size of sentences you need are tens or 100 hours. So trained a system like this, it's really a lot of CPU or a lot of clock cycles before we get to a decent model.
Okay, so Alexa has received these pressure waves, has converted them into digital information, pulsed that over to Southern Carolina. That's gone through the automatic speech recognition. Then that comes back. Tell me more about the natural language processing.
Yeah, the natural language processing, as I touched it very lightly, naming the entity as well as the intent. These are systems which try to extract the meaning, which try to comprehend what has been uttered. And that's the key issue, or that's the key problem we are solving with our system. We use different algorithms. Many of them are using also the neural networks. There are various types of neural networks. And these systems are trying to model what we call a natural language model. So the language model is, if I take the simplest approach, is a computer program which, knowing two words, knows how to predict or reduces the number of possible words which may follow.
Yes.
So this is some kind of a statistic or some kind of LSTM neural network or some other types of neural networks which are capable of doing this. And That's one piece of the work. The other piece of the work is that there are like synonyms, antonyms. So we represent every single word which is written from ASR with a distribution or vector, which we call distributions. These vectors are 300, 500, even more elements. And this vector space where these vectors live is linear, and it's interesting that it holds some parameters or holds some semantic features. So,
Yes.
it's getting too long. I understand.
Well, no, not at all. No, but it sounds interesting. It reminds me of when we're at school learning about languages, and one of the first things you do is you try to deconstruct any sentence into, let's say, verbs, adjectives, nouns. So it sounds very similar that you're creating algorithms which are taking this verbiage and finding the intent, the entities, and then making sense of those to formulate an answer afterwards. But okay, so that's some of the basics behind what's going on in terms of what you're developing. But as you mentioned there at the end of your presentation, the fact that you came very high in the awards for this prize is because you weren't boring, right? It took a long time for the adjudicator to press the button saying, "I'm bored of this conversation." So what's the trick? How do you get AI not to be boring?
Well, that was also part of the presentation, but I might not have put it that explicitly. We try to find what is interesting for people having access to these social networks such as Twitter or Reddit, where people are trying to discuss something what they like.
So you're suggesting that it's about content.
That's correct.
It's about content. It's not about style so much.
Well, it is also about style. Certainly, if I don't know, some famous player says some joke, he knows how to really put it so as people really laugh.
And I think there's many of the most famous orators that have ever been. I think they're the biggest thing in the reason why they're so famous is their skill of their use of language.
Absolutely.
Their command of language.
Absolutely.
So it's not necessarily about the information contents, but it's their skill at using language in an aesthetic way.
Yeah.
And I did notice how when speaking to Alexa that there's often she uses ways of language that support what you've just said, to congratulate you, and you can see she's trying to charm you, which reminded me of. I was thinking that might be a very much something which is one of the goals of your work.
Yeah, we do it partly because the TTS includes something which is called SSML, which is a speech synthesis markup language, and this allows us to command prosody, where prosody is the melody of voice. We can also do stops, like, to point out something or emphasize certain words or change the pitch, etc., etc. So we can do many things, but it's still not enough to imitate famous stars.
Okay. Before coming on to some questions we're receiving from our viewers and audience at home, let's talk a bit about the implications of this technology, looking into the future, maybe. Your presentation did allude to what are the current,
yes.
And you even mentioned you were quite surprised by the actual, the rank, what this technology is currently being used for. So you've already mentioned what are the roles of this technology is currently in society. Where do you think that's going? How's this going to develop? Where are we going to use this more and more?
Well, in the nearest future, or this is already happening, we will have much richer conversation, for example, in our cars, because their eyes and hands are busy, and natural language is the only way how to communicate. So I can really envision a car, you open the door and the car would say, "How are you today, Mike? Everything is going well. Yesterday you were sad, but today I tell you a joke and it will be a fine day for you," or something of that nature. Then you would say, "But today I have to go to this and that location, and the navigation will be set, etc. And going up, the system may say, but Michael, did you know that there is a castle from the 14th century, etc. And you may discuss details. So there will be some sort of entertainment as well as giving you some education. And that's definitely what we will see soon.
So I'm going to have a friend in the car.
Yes, absolutely.
And this friend's going to know me. It's going to know, it's going to be in sync with my calendar.
Yes.
It's going to know, this morning it would have known that I've got a meeting with you this evening. It could have suggested to me things I could listen to or watch to make our discussion even more interesting.
Absolutely.
It's going to know, it's probably fully synced with my social media. It knows all about what I like, what I do, what I don't like.
It can tell you, like, Michael, I suppose you go to visit your sister last time. You bought a bunch of flowers.
Better buy chocolates
this
this time.
Florist. So do you want to stop there again?
Yes, yes. Well, but I can also, so it's a friend. Will this friend, can we trust our friends, these AI friends?
Well,
would it be easy for other people to gain information about me through my AI friend?
Well, with cars, maybe not that sensitive, but we can imagine that we would have digital therapists, and the digital therapist will create your psychological model or psychological profile. And there are information which we really don't want to share with anybody except our doctor. And clearly there are these days already regulations, or maybe not already regulations, but suggestions, and the applications are inspected or tested whether they allow to erase the data, whether they are like HIPAA compliant or GDPR compliant. So there are many different standards the application have to meet so as they can be offered to users. And certainly privacy is top of the concerns, and it's being, many times discussed, and it's a hot topic.
When I've got 3 young children, when children learn to speak, they of course improve with practice, and the amount of time they spend speaking to their parents, they increase their knowledge of a language and their capability to use that language. Is it the same with these AI systems? Do they gradually get better and better as they use this capacity more and more?
Well, the field of artificial intelligence is these days dominated, or this is the only sort of algorithms we have at hand is machine learning. And machine learning is nothing else than having a really large number of examples. And the algorithm or the mathematics which is behind is actually trying to extract the information from these examples. And once we feed to the algorithm something the algorithm hasn't seen before, it tries to find to which class of what has been taught or what has been trained, which class is the nearest one, and this is typically an output of a classifier.
Yes.
So there is a process of learning.
Because I asked, when thinking about this subject, I was speaking to a friend of mine who is a professional translator of Czech into English, English into Czech. And he uses software now, which does learn. So it learns in a sense that it gets used to repetitive sentences that are being used. It understands the context in which they've been used. And it learns how to get better and better and better at picking the right words, the right sentences. And I think in many ways, as people's language improves in the sense that their articulate nature becomes better and more profound as you use the language more. So I'm looking forward to listening to devices and hearing that development.
Well, what you've mentioned is not just part of special software for translators. It is now part of editors or part of our emails. So the system receiving your email suggests how to reply. And since the system knows who is replying, it remembers as it is gathering your conversation, it remembers what words you use or what are the combinations, what are the sentences, and based on that they suggest. So then you can really shorten the reply up to hitting the tab and then hitting enter, and that's it.
Okay, Jan, let's turn to some questions we're receiving here. So the first one, good evening. How fast is the development in conversational AI? Do you expect that Alquist to be much different in 5 years' time? So that relates to our discussion about the future. They mentioned 5 years. I tell you what, let's talk of 10, 15 years. Let's give you a bit more time.
Yes.
What's going to be happening?
2030, which is 10 years. So that's certainly, I hope that we'll be much further away than we are today. Today we are approximately like before 2000 on the web, because the browsers and the pages and everything on the web was developing or starting developing or accelerated in after 2000. So we are in the early beginnings of conversational systems. And I believe that we will do much larger systems. We will have access to larger knowledge databases. So we would be able to answer the sentences much richer. Today we have, for example, algorithms where if you use just a sentence like the car goes, and we may have a neural network which is capable of making the sentence much richer, like saying the beautiful, strong, nice car is going down the road, and maybe saying even very quickly. And this can be generated by a system which was trained on billions of words or hundreds of millions of sentences. And this is already doable. And we definitely will proceed, or we will make this richer and richer. These algorithms are research algorithms. They are still not ready for prime time, because generating sentence like this takes enormous number of clock cycles. So the latency is long. But I think that in 5 years, because usually the research goes that we have algorithm which is precise but takes enormous time. So then a new group of researchers jumps on it and make it quicker. Maybe the accuracy a little bit decreases.
So there is sort of a payoff between, you either have high levels of accuracy or you get a faster response.
Absolutely, absolutely.
So we're looking at sort of increasing that, getting a faster, higher accuracy rate in terms of the question about the future, and also the depth and the complexity of the answers and the language.
Yes. And
so the experience is going to be far more like as if talking to a real human, I suppose.
Yes, well, that's the target. We'd like to emulate real human, but we are far away from being able to emulate real human.
Well, let's go on to the next question. So in terms of emulating humans, it seems that the question is about what percentage of people prefer the female voice when speaking to their device as opposed to the male.
Interesting question. Just recently, I don't recall where I read it, but there was a quote that 4 out of 5 bots are using female voice. And they were arguing that so as to forget the old gender stereotypes, this was a commercial, they have developed genderless text-to-speech. So
Genderless text-to-speech.
I don't know how it sounds because there was no sample, but obviously as the long history is showing us, ladies are nicer to hear to, or are more emphatic, and that's part of serving customers. So this is, I think, the main reason why to use female voices.
I see. Do you have a personal preference? Do you prefer to listen to female voices?
We have actually, our recent systems are using female as well as male voices, and we start to do some systems which carry such a dialogue, like lady is carrying on the concept, and the man is, for example, giving details or some kind of arrangements of this type.
And I've noticed it's often using an American accent. As this is Czech Centres London, I mean, I'd prefer, of course, to listen to a British accent on that. Or is that something you can just pick?
Well, no, you can. The Alexa as well as Google has UK versions as well as US versions, and they have the Indian English and they have Australian English. Even I think there is even Canadian version. So when you buy it, you actually localize it. Since we use since we have our algorithms in North Carolina, therefore we are using the American accent.
Right. Also, regarding the future, you mentioned that there's going to be a big, in terms of conversational AI, one of the main focuses is in the car. And car manufacturers now often talk about their products, cars, as being the largest computers that people now have. It's going from being a vehicle to being an experience, a place where it might be automated. You're going to be using that time more effectively for working, for pleasure. So conversational AI is going to play an increasingly large role in that development of the car. Now, one thing that happens often in the car is you're not alone, and there'll be several people who are involved in conversation. So my question is, how do you see it progressing, this technology, in terms of these systems being able to handle not just one-to-one conversation, but participating in a group conversation where there'll be perhaps even different accents, different modulations of voice, different volumes? Will these systems be able to cope with such eventualities?
Well, today we have the early, or we have done the early step, like Google Home as well as Alexa, both of them, they use so-called microphone arrays. And the microphone arrays, this is a system where they use multiple number of microphones, and because of having the same thing as we have 2 ears, so as to be able to localize where the sound is coming from. So similarly, the systems actually understand or can find out where the sound is coming from. So
Right.
this is the first step. So if there were like two in the car, say, there was a passenger and the driver and the mics are in the middle, somewhere where there is a mirror, then we would be able to recognize who is talking. That's first thing. The second thing, of course, is like if we were in a room and we were in a bigger distance from the microphone, like the microphone will be like 5-6 meters from where we are next to each other, we can use something which is called diarization. Diarizations are algorithms which actually based on the pitch or based on character of the voice can distinguish between multiple speakers.
Who's Jan and who's Michael?
Exactly.
Because before we started, when we were having a conversation with Alexa earlier, and you began, and she immediately recognized your voice and recognized you as Jan. But then when I entered the conversation...
Yeah, the system is not that smart, you know. It recognized that's me because
it's yours.
The device is mine.
It's yours. But nevertheless, that's the illusion that it creates, right?
Yes, exactly.
And but when then I contributed to the conversation, it assumed that I'm you.
Yes.
So we're still away from that. But okay, well let's ask another question. Can Alexa be taught humor? I mean, I began this evening with asking her for a joke, and she was successful in telling me one. But what is the level of sense of humor that these devices can have?
Well, certainly they don't have any sense for humor. Everything what is humorous or what sounds like to be jokey, this is what is inserted by people, because as I said, we are only limited to machine learning, so we have to have a bag of patterns, and the patterns are labeled like yellow, green, blue, etc., or rectangle, triangle, etc. And from these we can learn, but we have no idea about what is absurd or what is naive or anything of this type.
But are there serious research efforts in trying to teach these systems sarcasm, if not humor?
Well, certainly people try, but this is research and it's very far. What we can do these days, for example, is to say this is a positive sentence, this is a negative sentence, and this is neutral. And we can also judge, for example, like paragraphs. Is this paragraph positive or negative? But just to give you an example how difficult it is, you would read a review of a horror movie, and it would explain the plot full of blood and dead people, etc. And then at the beginning there would be a sentence, but it's not really not a bad movie, and not really bad movie. These are only negative words, and after all, the review may or the review is concluding that the movie is good. So it is very hard and it's very tricky to actually do the recognition of what is positive, what is negative.
Do you believe that it will happen? What's your confidence in that?
Well,
I mean, it seems to me this relates actually to another question, which I think is a highly philosophical question. I mean, is this really AI? Is this really AI?
Yeah, this is real AI, because this is all based on the machine learning algorithms, and definitely this is already happening. And the fact or the example I gave, this is something what we don't know how to do, or probably we would do a mistake, because all these machine learning algorithms, be it speech recognition or semantics recognition or entity recognition, etc., everything is not perfect. We can do it with certain accuracy.
I think what the viewer might be getting at is that for it to be true intelligence, then there has to be some sort of feedback loop, some sort of self-learning loop.
Yeah, but
so in the same way as children at the beginning also don't understand sarcasm.
Of course,
so
of course.
They're able to recognize.
They are able
speech,
to learn.
They're able to understand words, and then at the beginning when you use sarcasm as an adult, they don't understand, of course. Then they notice that the adult laughs, and then they explain, and from the explanation they learn, and they use their intelligence to actually then recognize the sarcasm. What is that human recognition of the sarcasm? Is it about the modulation of there's two possibilities. It's the modulation of the voice.
It's all.
And also it's the context, right?
It's all.
It's contextual.
And also, I can see you, so I can use your body language, I can use your mimic, I can use your gestures.
Well, will these systems also use? Because
you
can put cameras, for example.
It is very hard to say. If I give you a picture and there will be like, say, 5 pictures, and there will be persons, and some of them will be sad, some of them will be happy. And if I give it to you to label it, is this person happy or sad, and then I use another person, I am sure that it won't be 100% the same. And that's the problem, that if there is a human in the loop, and the human has his or her background, or the education they came through, or the social background, or many other things, so they may differ in opinions, they may differ how they express the things. Even if I say a sentence and there will be 5 different people in front of me, in their mind the sentence will be sort of understood or comprehended slightly differently. And these nuances, this is of course very difficult to embody into our systems. And right now, the science is at stage where we are trying to start to learn how to learn. Because the learning we so far are capable of is still very simple. And what you are talking about, this is a question of general AI and general artificial intelligence. That's
it's a composite.
far away.
That's right. It's a composite thing. But I've seen, I've watched on YouTube fascinating short films where they project into the future these hybrid uses of various technologies, including the ones that you're developing in conversational AI, but also with the kind of a visual AI that can recognize in human faces emotions. They can predict, the mindsets of people based on these mathematical symmetrical analyses of the face. They can recognize faces and compare them to social media to actually find out who that person is and display information about that person. So in these films, they often wear some glasses where there's a continual exchange of information based on all these technologies together to augment your understanding of, say, me. We meet for the first time in a bar by accident, and immediately your system informs you, it gets into my social media, recognizes my face, it gives you information about who I am, what I like, what are the most, if you want to sort of, if you want to get to know Michael better, these are the things you'd be talking about. He likes to drink this and not drink that. He likes this kind of food. So all these possibilities are there.
And do you wish to enable these capabilities?
Well, that was going to ask you.
I think that most people want, you know.
Well, no. Would you? Is this something you would like to take, Alexa?
Maybe inside the company, but limited to the knowledge of the company, because what you have been suggested, this is like a huge invasion to privacy.
Well, it means it's an augmentation of you yourself, so that you've got this almost a second you that can feed you with information that at a touch has got all access to the internet of everything, is extremely within milliseconds can find out whatever factual information you need, can access information which can be extremely interesting to you. That's quite a powerful thing.
Certainly, what you are describing is something like a digital twin, and obviously we see this in literature. And if you go back in the history, like '68, there was this 2001: A Space Odyssey from Kubrick and Clark, and lots of the things that time were envisioned are already in place, but
yes.
The whole the computer, we are still far away of the capabilities of the computer. So definitely people think about these problems or think about future, and we have better and better predictions, and of course all this is still boosted by the social media and press, where people are very much overestimating what we know today. But I certainly agree with you that the vision you have described, that's something which we may have, I don't want to say soon, but the profile like some companies are building of us contains a lot of things. You might be surprised that some of these companies will know how many brothers, sisters you have, where you live. They definitely know where you live. They definitely know where you work, because when you get to the car and turn on Google Maps, they tell you today you have to take a different road going to work, because they know that you go to work every day 7:15 and etc., etc. So this is already happening. Unleash it in the way as you are explaining. That's another step, because this data in some form or in a limited form exist. But certainly in the future we can look at these health applications where we will have the context, which is the history, location, time, habits, and millions of things which put together the context. And based on that, having access to huge data of this type, we can predict what may happen. So if we had all the medical records of all people, we may find correlations medical doctors haven't found, meaning that we would, for example, find some symptoms of a disease, and because of having this in huge sizes, we must suddenly find that it was caused by something which never came up to our minds.
Ladies and gentlemen, a fascinating insight into our possible future. I'm sure you will agree. That unfortunately brings our time to a close. I hope you've enjoyed very much our discussion, Jan Šediví's presentation about the work here with the Czech University,
Alquist.
yes, and at Alquist AI. Jan, I wish you all the best, all the luck. I hope you continue to enjoy the work you're doing, that the developments go as to planned. I'm very much looking forward to stepping into my cars of the future and speaking with them and teaching them a bit about cricket, perhaps, or whatever it might be. So thank you very much for your insights. thank you very much at home for tuning in and learning a bit more about conversational AI. I would like to thank also, of course, Czech Centres in London, of course, the town of my birth, so well done and thank you very much. Of course, Czech Technical University, where we're sitting currently, and is the university where you're doing your work, Jan, and to our partner, Avast. So thank you very much for them. Do tune in on the 11th of November. We shall have the next AI Science Café, and it will be with Mr. Tomáš Krajník, and he'll be talking about how robots are changing our living environment. So that'll be the next conversation. It won't be an AI conversation, it'll be a one-to-one with a real humanoid, but I'll look forward to that. So thank you very much. Do tune in next time and take care. Bye-bye.
Thank you. Good evening. Bye.